bring to this platform industry players to share knowledge and information with the members of MWA and viewers of this webinar. Thank you to both speakers for willingness to spare the time with us this evening, this afternoon. Mr. Amoste, I hope I mentioned, I pronounced your name correctly, and also Ms. Pek Zikan. Okay, I will not be introducing Borouge here because I think you will do a little bit of it probably later. I think that's also important for us to know. But more of my short welcoming remark, I will be touching a bit about the industry as well, because I believe that there are also participants that come from overseas who are maybe quite new to this water industry. So in MWA, we actually produce this book. They call it Industry Status Outlook Report. I think for those who are not familiar with this industry, with Malaysian industry, or maybe due to the lack of access to the government or to water operators, probably this book will actually help you to understand the industry, maybe pertaining to what we are going to discuss today, pertaining to pipes. You will get from here what is the condition of our pipes, what is our non-revenue levels and whatnot. So this is very important for you to really understand where we are now. And I think polyethylene is not something new, but probably there are some new things that probably the industry can share. So that's why I think this is a very good opportunity for our members as well as the other viewers, that today will be exposed to something that probably will give some better understanding of polyethylene as one of the materials to be used in this industry. And MWA, besides doing webinars, we also have publications. I think just now the MC have mentioned few publications, our design guidelines, and also our publication. We will also be coming with the latest publication of the Malaysian Water Industry Guide, probably by the end of the year. So that will give members and also other interested parties in this industry a better picture of the status of the industry for you to work with, and then I think that will give a better idea what type of pipe is suitable and where it is good at. So that will help everyone to adopt the best technology for the best purpose. So I think I'm not going to take much of your time, our friends from Borouge, but I hope this will be a very interesting presentation for us to listen and also to learn more about the product that you are going to discuss this afternoon. So, and also to our members, to the participants, the viewers, I think I always say that thank you for your support. I think it's not going to be the last, so you'll be meeting us more every now and then, because I think this is the only way that we can actually meet and share information with members as part of obligation as this MWA as a national organization that is leading the water fraternity. So thank you very much, the organizer, for all the arrangement made. Thank you very much to Borouge for being kind to be part of our webinar speakers and also organizer in one way, and also to our viewers who are actually very patient all the time. Terima kasih banyak-banyak lah kerana sentiasa bersama-sama dengan kita, always with us and our programs. So I will be spending my time mingling around with you all. Now I cannot because I'm speaking. So probably later I'll find out who are here and who are still not here yet. Okay, thank you very much. All the best, Amoste, and also Pak Zikang. And I hope it will be a very interesting session this afternoon. Thank you very much.
Thank you so much, Dr. Tajik. Now I'll pass straight to our speakers to start with their presentation.
Okay. Good afternoon. Can you hear me and see my screen?
Yes, it's clear.
Okay. Perfect. Thank you, Mr. President, for the opening, and congratulations to MWA for your new publications. So today we are bringing to the webinar Best Practice in Water Transmission and Distribution with Polyethylene Pipe. First, a few words about Borouge and our commitment to sustainability development. Borouge is a polyolefin company, as my background has shown. This is our production plant in Ruwais. We are a company formed between ANOC and Borealis. Together, we have 3,000 employees globally, and our Ruwais polyethylene and polypropylene complex has an annual capacity of 4.5 million tons, and we are on our 4th expansion phase. We also promote innovations. We have state-of-the-art innovation center in UAE and application center in China. Our mission is value creation through people and innovation. With response to global warming and climate change, starting from our parent company, we have a strong focus for sustainability development. Our parent, ANOC, is one of the lowest carbon-intensive oil and gas producer, and we are strengthening on that position to have a 2030 sustainability goal to further reduce our greenhouse gas intensity by 25% by the end of this decade, and also expand the carbon capture capacity by at least 5-fold by 2030. That is equivalent to 5 million acres of forest to take away the carbon dioxide generation. And for Borouge, our Ruwais operation works on a sustainability strategy based on 5 pillars, which are to reduce flare, energy consumption, waste, water, and also greenhouse gas emission. Year by year, our energy intensity and also greenhouse gas intensity has been reducing, and we are striving to be one of the lowest greenhouse gas intensity polyolefin player. A majority of our 4.5 million production capacity are dedicated to producing innovative infrastructure solutions used in the area of utilities, for example, gas pipes, water pipes, construction like polypropylene for hot and cold water, and underground sewage system, as well as industrial application for corrosion protection and transportation of industrial media. Now, for our products, polyethylene, going into the pipe application, it has a positive environmental impact compared to traditional material. This is a study by the European Plastic Pipe Association comparing the carbon footprint or environmental impact of polyethylene versus ductile iron. Now, this is done on the basis of underground pressure piping for drinking water for 100 kilometer length and assuming a service life of 100 years. Polyethylene is only a fraction of ductile iron in terms of environmental impact. This is assessed across the whole life cycle of polyethylene and ductile iron, from the product raw material to construction of pipe usage and end of life. In the area of impacting the environment by taking resources, contributing to acid rain, impacting marine life, contributing to global warming, ozone depletion, and also smoke generation, polyethylene is actually much more environmental friendly. This is mainly due to its lightweight and ease of installation that allow fuel efficiency in the transportation of the pipes. It has long length and coilable system, reducing the number of joints. Hence, less men and machineries are being used in the jointing system. The operations are also using less pumping energy because of a smoother bore with very low coefficient of friction. And for maintenance, because of the joints secured, so secure that there is very low leakage and low maintenance required. As well, for the end-of-life treatment of polyethylene, this is a fully recyclable material. So with our products, we are also contributing to the Sustainability Development Goal of the United Nations. For the UN Sustainability Goal number 6, clean water and sanitation for all, our innovative plastic solutions are supplying clean water to homes around the world. And we have a corporate social responsibility program, Water for the World initiative, that has positively impacted more than 800,000 people around the globe. Now, polyethylene is not something new. It's used for water and gas pipe because now we have more and more focus on sustainability development. We would like to also touch a few points on it's been a sustainable and lower whole life cost solution for the water transportation. So where can actually polyethylene be used? It's used in water transmission and water distribution. So for water transmission in the high pressure and large volume transportation of water, we can use polyethylene for corrosion protection, like a 3-layer system with epoxy, adhesive, and polyethylene top coat. It can also be a standalone large diameter P100 pipe up to 25 bar at SDR 27.4. If the pressure and hence the wall thickness allow, polyethylene pipe can be made up to 3 meter or 3000 mm OD. So this is actually stipulated in ISO 4427, which is the ISO standards for PE material used in water pipes. In the area of water distribution, P100 and P80 could fully cover the operating pressure requirements. It has a leg-tight fusion joint, resistance to ground movement because it's so flexible, and is generally resistant to acidic and basic soil conditions. For transportation of drinking water with chlorine, chloramine disinfections, polyethylene is able to operate well within the aesthetic level. Now, if we talk about non-revenue water management, it starts with a good pipe system. Your assets must come with a reasonable lifetime expectancy, and that is depending on a cycle of many factors, starting from a correct pipe design, pipe material selection, production, installation, and jointing. Today, we would like to focus on the material because this is what Borouge specializes in. We have 20 years of supplying PE material into this application. Also, our other parents, Borealis, has been in this, the leader of polyethylene for infrastructure application for more than 50 years. Okay, so polyethylene pipes are widely chosen for new development and asset upgrades for water application. It is resistant to corrosive soils. It's so flexible that it can be coiled in very long length, even for pipe size with OD 180 mm, it can be coiled as well. Hence, it is quite resistant to ground movement. If in any cases of earthquakes, if we look at the failure situation or statistic of all the piping system, polyethylene would be the one with the lowest or even no failure. With respect to temperature and weather change, unlike other material which might have more failure in winter or summer because of the soil conditions have changed according to the climate, polyethylene is generally resistant to such temperature change and weather change. From operating point of view, there might be water hammer and pressure surge, but polyethylene is quite resistant to short-term pressure change up to 3 times its nominal pressure. In terms of corrosion, it definitely does not have corrosion like what traditional material have. Hence, it's able to maintain a very low coefficient of friction in the inner bore throughout the whole lifetime of 100 years. For polyethylene used for drinking water, it has a specialized additives package that should not be detrimental to health. So it's able to maintain safe drinking water quality. Now, okay, we are aware that cost is also a very big consideration when we are deciding the material for the piping system. However, if we are just comparing the cost of pipe itself, this may not be giving us a full picture. We should be considering the whole life cost of the system that consists of not only the pipe, but also the installation cost for a real project. A real project could be happening in a busy road in the urban settings, whereby you need to take care about traffic management, resurfacing of the road, and also manage much thing you want to have something that can be installed as fast as possible. As well, we should look at the future operation and maintenance and repair costs of the full system for the whole expected lifetime of the assets. For example, 100 years. So a way to do whole life cost is actually to build a model of a piping system. In this case, a 5-kilometer pipe system with 2 branches, 4 sluice valves, and 2 air valves. And we're going to compare the whole life cost between 3 materials: ductile iron, GRP, and polyethylene. So the size is 400 mm for ductile iron and GRP, and 450 for PE, which is dimensioned by its outer diameter. So this is done in the UK context, in the urban situation. First, we look at a 5-kilometer pipeline for the installation cost. As we can see from the bottom, maybe for the pipe cost itself in the orange portion, the picture may not look so good for the more innovative plastic material like polyethylene. As well, excavation and removal and installment costs could be quite similar. However, when it comes to joining and traffic management cost and staff and site supervision, polyethylene actually is much lower because it has less joints, it's faster to install because of the lightweight use of less machinery, and also it does not really need anchor blocks. So this speed up of installation also reduce the total installation cost. Now let's look at repair costs. So this is based on the UK Water Company's statistic of failure. For ductile iron, the failure rate per kilometer per 100 kilometer is 7.5. For polyethylene is half of that. So that would correspond to a much lower repair cost for the whole lifetime of the system. In this case, assume at 50 years. So in total, if we compare the whole life cost of the 3 systems, even though the upfront cost of pipe is much higher, but in totality of the whole system cost is actually much lower because of faster installation, lower repair cost, and lower operating cost. Now, we would like to also give some tips on best practice in water transmission and distribution with polyethylene pipes. Not all polyethylene is the same. We have also seen polyethylene being used for packaging, disposable bags, being used in rigid packaging like jerry can. But what is exactly needed or specified for PE material used for pressure piping? And then there is actually, always a way to go around by using a mix of material, like a natural PE with some color master batch. And that is actually quite detrimental to the mechanical performance and joint integrity of the pipes. And later on, we'll show studies that we have done to prove that this is actually quite a bad practice. So PE has been used for a long time, especially in the gas. It's one of the best material. Over 50 years of track record starting from the 1970s, PE has been used for gas, and we know that this application cannot tolerate any failures. So as we can see here, starting from UK, they have been using orange pipes and yellow pipes, so PE 100 and P80 respectively for gas pipe. Coming closer to us in Southeast Asia, Indonesia is also having quite a boom of gas piping requirement, as well as India. So India have a lot of city gas distribution projects going on, and they will only specify compounds, ready-made compounds for gas application. And for water, in the water arena, over 70% of new water mains are using polyethylene in Europe. And this is backed up by the UK WIR Water Main National Failure Database. As we can see that polyethylene in the yellow bar has been maintaining the lowest failure rate per year. A more recent study in 2020 done by Dr. Timothy for Anglian water region is about the impact of environmental factor on the leakage of their piping system. We can see that the cyan bar refer to polyethylene. Polyethylene has the higher portion of kilometer of pipe length being used. It's used so much. However, the failure rate is on the very converse of very low. Yeah. So this is based on a lot of reasons because the Anglian region in UK is very aggressive in the soil condition. It has clay that have high shrinkage. So all the brittle system like AC pipe, even some of the older generation of PVC are failing during the summer when the clay is drying up and shrinking. And in the winter, metallic pipes will fail also in quite a lot. Yeah, so they do have a weather conditions to consider, and they find that PE is one of the best material, and it's always the material that they are now considering going forward. So we still see that there are some failure for polyethylene pipes, and for this case at Anglian region is usually because of the jointing. So for jointing with electrofusion, jointing electrofusion is actually quite a specialized way of jointing, and we need to have a good training with the welder. So if we come to our situation in the region like Malaysia, there is a aim to reduce the non-revenue water percentage down to 31%. And also historically, all kind of piping material has been used. Polyethylene actually make up about 20%. 1/5 of the piping system is using polyethylene. So I think it will be of great value for us to share with you what is a good material for pressure pipe application in terms of polyethylene. So there are many things we knew about polyethylene for pipe application. There are also some things we are not really so clear. There are some myths, some rumors, but I think this is a good platform to clarify. Definitely for corrosion resistant, polyethylene plastic system have no such issue. It's flexible and lightweight, and is able to withstand a lot of the ground settlement issue. The fusion joint itself is actually one of the best way because you don't introduce any foreign material into the joint, purely PE to PE with heat. But however, there's still a leak tightness issue, which we will address later. And how do we actually ensure 100 years design lifetime with polyethylene? Now, polyethylene pipes comes from polyethylene materials, and we are supplying them in ready-made compounds, these little granules pellets that consist of all the additives and carbon blacks that is needed for the whole lifetime. So it needs to fulfill certain standards, and we are showing you later. Okay, there might also be some question about chemical resistance. Generally, to acid and base, the polyethylene have no issue. For disinfectants used in drinking water, chlorine and chlorine amides have been used quite widely. In a normal temperature range, it should not be an issue. So what are the standards that PE material for pressure pipes should fulfill and comply to? In the gas application is ISO 4437. Correspondingly, there's a European standards called EN 1555. As you can look at the structure, there are 5 parts, even for ISO, 7 parts for European. This touches on general requirements on the material, on the pipes, on the fittings, the valves, fitness for purpose, and for the European side, also a guidance for assessments of conformity. Now, let's look at the water standards. The water standards actually are exactly quite similar to the gas standards, except for certain specific requirement of the gas. So we can see that on the standard level, the basic criteria or specification is the same. I also have a note here that the Malaysia standards currently is based on EN 12201, which is due. I think we have a version of 2011. It's going to be updated soon, and as well MS 1058 will be updated. With these updates, we are able to set or update the requirements of PE as well in various aspects, for example, slow crack growth and also MFR. Okay, so what are exactly written in these water and gas standards in the part 1 and part 2 for the material and the pipe? First and foremost, for us, where we are producing this PE for such a long time, we're focusing on the material properties. Material properties where we need to ensure that the granules are fulfilling all the performance requirement with these additives. And carbon black master batch has been added to have a UV protection. When it comes to carbon black dispersion requirement, it is also quite a detailed stipulation written there. Carbon black content needs to be between 2 to 2.5 weight%. There's pigment dispersion has to be rated according to the standards to have less than grade 3, not more than grade 3, and a dispersion rating of not more than B. The carbon black also have to have certain size, not too big, because if you have too big particle size, you're actually not having very good UV resistance. So 10 nanometer to 25 nanometer will do the job. So in terms of the material properties in the form of pipe, it must have MRS classification. So we have our ball-star technology to tailor-make a bimodal structure that is good for strength and also processability. However, we still need to prove to you that this is a material that can last for 50 years or even 100 years as a P80 or P100. As well, the other two pillars of the long-term performance are RCP and slow crack growth. RCP refers to the material resistance to internal pressure in very cold temperature. So for water application, it should be able to resist up to 10 bar for PE100. For slow crack growth, it's actually also needs some updates in the current Malaysia standards. It used to be a 165 hours, but now it's all revised, or the standard requirement is 500 hours. Last but not least, we need to look at fusion compatibility of the pipe of the material. So allow me to talk a little bit about MRS testing. So MRS is the minimum required strength that characterizes a PE material for pressure application. It is a test that will take us up to 1 or 2 years to complete, to certify that the material can go into a pressure pipe application. As you can see here, this is a very standardized way of demonstrating that the material has been done or evaluated for its MRS. We have about 90 pipes tested at 3 different temperatures with a spread of hoop stress, and then we do an extrapolation to reach 50 years and find out what is this hoop stress level. So this hoop stress level will be between 2 levels A and B. So a P100 material simply means that it's between 10 and 11.19. Anything above it will be, something like a P125, which still currently there is none in the market. So a P80 material will be something slightly lower, between 8 and 9.99 and so forth. So today in the market, basically, we are looking at P100 material with very straight curves. We don't expect to have the curves at 80 degrees C having a knee point going down like this, which signifies that the material actually is quite brittle and doesn't have enough strength. So why I talk about 100 years? From the material point of view, this line can actually extrapolate to 100 years. So 50 is here, 100 is just a little bit more. So nowadays, we are actually talking about 100 years lifetime with polyethylene material. Slow crack growth. Pipes are quite handled in the site, and sometimes we will be introducing scratches to the surface of the pipe. So when that happens, even when the stress is removed, however, the notch created on the surface of the pipe will start to grow into, to penetrate through the pipe wall. This is because the stress at the tip of the crack is always higher, and they are breaking the polymer chain over time. So a good material, or actually the more advanced polyethylene, has very good resistance to stress crack resistance. Today, the standards are talking about 500 hours by notch pipe test. There's also P100RC, which Amos is going to touch on later on, that has an even higher requirement for this property. Now, we are talking about carbon black being a very instrumental additives in polyethylene pipes. The function of carbon black is primarily for UV protection. Otherwise, the pipes under transportation or even above ground installation will be subjected to UV degradation that breaks the polymer chain over time. A good distribution of polyethylene of CB, carbon black, is very important. Does it make a difference if a pipe converter actually uses a natural material and add carbon black master batch in the pipe extruder? Yes, there is a difference, and we have done this study to show that a ready-made compound with granules already containing the carbon black and additives are actually much more secure way to ensure the performance and quality. Okay, so in our study, we did two approaches. One is making our pre-compound the normal way using our big twin screw compounder in our polymer plant, and then take these pellets and extrude the pipes. So we call it sample one. They are made of pre-compound material with the extrusion speed of 100%. We have a parallel comparison of using natural material, natural PE material, and add carbon black master batch, do a simple mechanical mixing and put it in a pipe extruder. And we have sample 2, 3, and 4. They are done with different speed. So 2 has the same speed as sample 1, 3 is 80% of that, and sample 4 is 60%. So as I mentioned in the ISO standards, they do require the carbon black to have a good distribution. So the distribution is actually like a protection against the UV. In the case of sample 1, the distribution is very nice. You don't really see any smearing white area. But sample 2, 3, 4 are actually quite bad. It's almost like the Milky Way or the galaxy that you see this white area with no carbon black. So how do they rate according to the CB dispersion? They are actually not fulfilling ISO requirement. They are more than B. So it can, in a very straightforward way, this is already not able to meet ISO requirement for a black pipe used in pressure application. What about the tensile performance of such system? So we did sample 1, 2, 3, 4. We cut the top bones from the pipes and do a tensile test. So according to standards, by performing a tensile test on the dot bone taken from a pipe, they should surpass 350%. But in this case, we find that the sample 2, which we try to run at the same extrusion rate as a normal system, could not meet it at all. So are the other 3 and 4, we actually need to drop the output quite a lot in order to fulfill these tensile requirements. So why is this happening? As we know that there is a very poor distribution of carbon black, creating this white area and black area. The black area actually have more carbon black concentration. So there is a stress point here. The stress point are the initiator of the failure, which occur much earlier than a normal tensile performance. So this is why that we actually find it very difficult to meet the tensile elongation if we do a salt and pepper mixing to produce the pipe. So what about the jointing? So if we are to join 2 pipes with very poor carbon black dispersion, is there any effect on the joint integrity? So we did this jointing comparison between sample 1 and the other 3 samples. So what we found out here, so what we did is, first we joined the pipe and then we cut across the joints in a cross section and do a microscopic analysis as well. And we see that it's a very homogeneous well because two metrics are quite similar. So the melts are able to flow between the 2 pipes. And we also make a very narrow waist sample across the well and do a tensile test. So when we do this tensile test, actually the joint is so strong that the failure does not occur there. In fact, it occurs a little bit away from the joint, and we can see very ductile failure. So in terms of fusionability, we are looking for a ductile failure when we pull the sample till failure occurs. And this can also be reflected by the tensile displacement and stress test. It shows that the stress is able to go over the U until a good elongation happen before the failure occurs. So what happened when we join those pipes with very poor dispersion? Okay, we cut the same way across the joint and do a microscopic analysis. We can see that there is not very good fusion between the two pipes ends. The different metrics of the white area and the black area are actually interfering the mingling of the melt front. So actually, how does this white and black area look? If we take a shaving from the pipe ends, this is how they look. We can even see through it. So this is definitely a very bad UV protection, as well as interference to the jointing. So when we do similar tensile tests across the well, we find that the failure point is at the well, and it's a very clean cut surface at the failure interface. So this is actually showing that the well is being compromised. The tensile test also failed in a very brittle way. Okay, so this is one way to ensure on the raw material side, we are able to secure the joint. Of course, when it comes to achieving quality joints as a routine, there are still many parts of the puzzle to complete. We have to look at the site preconditions. So every installation site is different. Maybe some have more water and we need to move the pipes to more drier area. Some are more windy and we need to have a shed to cover up when we do the jointing. And the way we are handling the pipes is also quite important. So for the quality of the pipe and the fittings, definitely the dimensions must be within the tolerance. And if during transportation we have kind of, deformed the pipes, then rerounding procedure needs to be adopted in the welding, which is actually quite a standardized practice. There must be established welding procedures, and it must be followed by welders who are certified and well-trained. And machineries and tools are well-calibrated and according to standards. With all these parts and pieces in place, we are able to enable a leak-tight joint so that, pipes are not always failing at the joint. Yeah, so I think we got all these photos from the European Plastic Pipe and Fittings Association. If you want to have more information, you can always visit the website. Yeah, there are a lot of good information there. So there are also no lacking of jointing procedures. So it's a matter of enforcement and implementing good practice in the jointing. Okay, so actually, as we show in the beginning, the PE gas pipes experience with polyethylene is very positive, and that is matched with a very stringent quality assurance system, starting all the way from raw material to pipe production to installation and operation. We should also translate this good practice to the water pipes so that we can successfully reduce our non-revenue water loss. Definitely, we can start with use of pre-compounded black. I know the Malaysian standards is already specifying pre-compounded black, but it's a matter of enforcement of standards. So the end user can, like water companies, can also set their own specification that's set a way to control the raw material, the pipe, welding, and installation, so that we have a full chain guarantee in terms of quality. And also, we can look at use of good welding machines, certified welders, traceability of the welded joints, and proper inspection to ensure the use of specified material and accounting of raw material batches and quality against the pipe produced. And as polyethylene is always undergoing innovation, we have advanced material. Every few years, we will have new material coming up. So if you have a demanding applications, you could also consider our high-stress crack-resistant material, which later on we will be touching on that. Okay, so today I actually have two colleagues from India also joining us in this webinar. I have taken their best practice success case in India to share here. This is Bajirata project. So why is this so significant? Now in India, they had also been using Hdpe for a long time. In the 1980s, however, there's a reputation suffer by the PE industry because poor material has been used, poor quality PE material has been used. It has been termed as a brittle material, and it has been banned in many states, including Andhra Pradesh. So this is because of widespread adulteration and poor manufacturing practices. But over the times, with good efforts, persistent effort of pipe producer and resin manufacturer, we are able to continuously supply the market with good quality pipes to regain the status. And more recently, there is a big project in the Telangana state for their water grid. They have implemented the largest ever water project utilizing 80,000 metric tons of Hdpe, and majority of them are using PA100 black material. So other projects also follow, like Kalishwaran project, which is a big irrigation project in that state, and other states as well, like MP, UP, Jarlingam, Rodisco as well, has specified PE black. So this is very remarkable because in India, we have the specifications still allowing the salt and pepper. But when you allow this is the risk that you could actually face the reputation loss of the material of a very good, potentially very good system. Okay, so actually we do offer a very unique service to the industry called fingerprinting that will help you ensure that the material you are using are authentic material. So I'll pass this over to Amos. Yeah, over to you, Amos. Maybe I'll stop my video.
Hi, thank you, Pexu, for sharing the information. I shall touch on fingerprinting. As Pexu has shared, this fingerprinting is a unique service providing to service end user to check pipe and fittings that are of material that is of good origin. So it's like our fingerprint is unique to us. Likewise, this every material that is produced has its own signature. So this we can test and to check whether this pipe is come from a virgin material or is otherwise. So this involves taking a pipe sample and sending to the lab for analysis and to measure some key properties and compare to reference. So we will be performing melt flow rate and density, additive content, carbon black content and dispersion, which is very important as seen from the earlier slides, where applicable because only for black you would have carbon black, and OIT, oxidation induction time. This is more for the additive performance. And this service is, as I shared, is offered free of charge to the to help the gas and water companies to test the pipe fitting, whether it's made of our PE100 material. Next, please. And this is to share success of these services provided to Chinese gas and water utilities. It has been started since 2006 and continuing until now, 2020. You can see there are 610 samples already tested. And from the 75% of non-borage material, it has in the market has dropped down to about 10 on the average. This shows a very important service that we provide to the company because a lot of pipes have been made, send it to the gas utilities or water utilities and say that this is borage pipe for your system. But actually, when they send the pipe to us, we test, and in the beginning, 75% are non-borage pipes, or rather, pipes not made of borage material. And now, the counterfeiting activity for these services in gas and water has reduced. Thank you. Next. Why do we do these services? This is to provide additional peace of mind that the PE pipe is made from a virgin material, and serve also additional verification process to increase the end user confidence, and definitely minimizing the potential expensive failure after counterfeit PE pipes were installed, because you have installed some counterfeit pipes. It will not withstand the service life, as what Pixel has shared about the leaks and all the damage and stuff like that. And then when you replace all the pipes, the cost is also included in the service of this system. Next. So much for fingerprinting to support the industry that good material has been used for pipe production. Let's move on to the next one. Is on the development of material that catching up with the market needs. First is the P100RC, and the second one will be large diameter. This is an overview of Borouge pressure pipe grades. So the one on the left is all the black grades, P80, P100, and P100RC. And then on the right is the color grades. These are typically used for gas application, which is very difficult to counterfeit because of the color code that is demanded by certain standards. Let's move on to the next. They talk about RC. What is actually P100RC? This is actually used or developed to meet the requirement of demanding installation at certain location that doesn't allow open trench. Thanks. This is a graph that shows the cost over the installation line, and also based on the diameter. As Pixel also shared earlier, when you do installation, the cost is very important for the whole system. So this this no dig helps to reduce all these costs. What is open cut? Open cut is basically open trench. When you want to install a pipe, for example, a pipeline, what do you do on the, if it's on the road? You will say, okay, I stop the traffic, I build a bypass so that the traffic can continue, and then I dig a trench, I open up, and some soil I need to send it for removal because I have to replace some of this soil with sand bedding, lay the pipe, and then I put the soil back and then surface the road, open to traffic, and close the diversion. So there is a lot of cost and time to do this project, to put in the pipe with open trench. But with no dig, you don't have to stop the traffic. Yeah, you have to have a place to install the pipe. Yes, but this footprint will not be very large because you are not opening up the trench. You are using some techniques that go under the ground and then go through the pipes or go to the ground to bring the pipe into the other joint. So this one is many way of doing it. Pipe bursting, base case, is a existing pipe, and you pull a PE pipe through, and then you destroy the original pipe. And then your directional drilling, base case, is there's a drill head that will help to drill through the ground and find the path, and then after that you pull through the pipe. And of course, the slip lining and other swells lining, all this you can see from the chart. The cost for no dig is so much lesser than the open cut. Also, in the environmental aspect, you can see that based on this installation specialist set, which is established by this Mr. Set, they presented a paper showing the environmental impact of different materials and installation methods. And they have shown that PE was 70% lower than iron in production, and also lower equivalent carbon emission in transportation because of its lightweight compared to the iron. And with no dig, the methods with PE show dramatic reduction, as you see from the chart. That the first one, iron pipe open trench, very high in CO2 per meter. Compared to the PE open trench, it is still less to the iron. And then when you come to no dig, directional drilling and pipe bursting, you see the carbon footprint is really, really smaller compared to the iron open trench laying pipe. And this environmental factor concern is becoming so popular, as we have seen in the market about sustainability and so forth. So this is a trend that is coming, and definitely will be part of a tender to put in the sustainability or environmental impact into the requirement. Next. All right, now we talk about this RC. What is RC? P100 RC is raised crack resistance, or HSCR, high stress crack resistance. This has an improved slow crack growth resistance, which Pixel has shared earlier, the graph. When you have the cut in the pipe surface, this growth will take time and grow through the wall thickness, and then the pipe integrity will be suffered. But with this feature, this slow crack growth will be there, but it takes a longer time to grow through the pipe wall. This material is preferred for this installation like no-dig, horizontal directional drilling, because you're going through the soil and you don't know what's inside the soil. There may be some hard stone that may be cutting the pipe when you pull the pipe through the ground, and also pipe plowing and other techniques. So with the current EN standard is development is still in developing, and we'll be defining this RC requirement, and then we'll be able to see what stipulates RC, what is required to be achieved by the material in order to call it the RC material. So much for the installation pipe that's specially designed, I mean the pipe material designed for this installation of demanding area. So now we move on to the next one. This is the large diameter pipe, or rather material designed for large diameter and thick wall pipe, which is the HE3490 ELS. This one is especially for industry, mining, or even nuclear plant cooling pipe system. It's been used for this application. This material has been used for this kind of application. Next. Yes, this is also similar to earlier slides that when talk about pipe material for PE, it can upfront be more costly than the traditional material, like in this case in the chart, more costly than the iron. But this is just talking about the cost itself of the pipe, but it doesn't mean the whole life costing, as I mentioned. So that this is may have give you a setback. Say, okay, the price is too much to pay for a PE pipe, but I'd rather buy a steel or iron pipe, because the thickness don't increase too much for traditional material, iron and steel, but still take the high pressure. But for PE pipe, the thickness has to increase with the to take in more pressure. That's why the cost could appear more expensive in the beginning. Yeah. So with this new material, designed actually for wall thickness more than 80 mm, because normally if you have a standard P100 low sag material, which is on the left, you can see that the material build up at the bottom, because when material extrude from the machine, because material is still molten, it flows downward. When it flows downward, it accumulates at the bottom, like maybe 4 to 7 o'clock area. So this increase in the thickness at the bottom, and you have to do a lot of adjustment and some scraps in order to get a reasonable distribution of this wall thickness. And this could cause a wastage of material, manpower, and also energy in terms of producing the pipe. So with this ELSH material, because of its more resistance to flow against the gravity, the material, the pipe come out, you have a even or better wall thickness distribution across the circumference. This will reduce your cost in terms of material wastage, production cost, there's less scrap, and then of course man hours and stuff, all these are included. So there's a lot of saving. So if you look at the chart on this right side, This is just a viscosity versus a shear chart. Okay, the dark one is the ESL's H, and then the lighter color is the standard P100. So when you see that it's nearer to the y-axis, means the material exceeds the die, so there's zero shear. So when the material come out from the die, typically when they are molten, they will flow with the gravity and go downwards. But the darker color shows that it has a higher resistance to flow, so the material can stay in a good shape around the circumference. It's better resistance against the gravity. And then, of course, if you look further down, the higher viscosity or rather shear rate, you see that the viscosity is similar to the standard P100, meaning that the processing of this ELSH and the standard P100 is similar. So there is no impact to the processing condition when you make this pipe. Yeah. And by the way, the PE pipes can reach up to 2.5 meters already in Asia South. Here is just an example of this material being applied. So in Vietnam, pipe producer is this Thiên Phong Plastic, or known as T4 Plus. They have this project in this Minh Phu project. They are for this supply of seawater into the prawn farm. So the pipe sizes made were 1200 to 1600 mm, SDR 11 to 17. So the thickness of this wall thickness range from 94 mm to about 109, which is very thick wall. And typical material will not be able to achieve this thick wall without a sagging phenomenon. So their challenges was to find a suitable P100 material that allow the production of this large diameter and yet even wall thickness. Also, this material need to be resistant to corrosion by the seawater because they are transporting seawater to the prawn farm, and need large volume. And you know that pipe, there are other traditional pipe, maybe steel or ductile iron, they will have a encrustation, and then the pipe wall, the bore will be smaller. But with this PE pipe, the bore doesn't change. So the volume of water will be consistently filled to this prawn farm. Also during the installation, because the sea water is taken out, and then the pipe has to lay, and then through the sand dune under the river before they can reach this location of this prawn farm. So with this material, a solution has been created for them such that this pipeline is durable with minimum maintenance costs to ensure the stable operation of the prawn farm. So much for the PE material. Pixel also highlights about 3LPE, 3-layer PE coated steel pipe for high pressure water mains. PE pipe can only withstand certain pressure, and if you have exceeded the pressure, there's no way a PE pipe can be used. So a steel pipe can be used to transport water for higher pressure. Let's look at this PE. You see the picture is a 3-layer Hdpe, top layer, and then you have the adhesive layer, and then you have epoxy, and then the steel. So this is 3-layer PE. This is a standard configuration. So for the India oil and gas industry, 3LPE coated pipes are standard solution for corrosion protection of the steel pipe. Okay, because of the exposure to the elements, so you need to protect the steel pipe from corrosion. And it's about 90% of the market share. And globally, 3LPE is about 80% market share with a long-term record of about 30 years. And this 3LPE is combined with oxygen barrier of FBE, which is a fused-bond epoxy, and high moisture barrier with mechanical protection from Hdpe, which protect this steel pipe. And we all know that how rust come about is you need oxygen and the moisture. If you are blocking this oxygen and moisture from the steel pipe, and then you are protecting the steel pipe from corrosion. Yeah. And this application can be done in fully automated so that the materials is of a good quality. For water transportation, it can be done through open channel like you see in the diagram. Yeah, you basically a canal and or open channels and other ways. But this open channels or canals, there is a high level of loss of your water, about 40 to 50% through water seepage to the ground and also through evaporation because they're open. Yeah, especially in hot area or summer, the water evaporation rate is very high. And this can be prevented if you have a pipe transporting the water. So buried water pipe, you are using the land in a very efficient way because on top of the land, you still can use the area for other activities and still provide high volume of this pressure water that's been pumped into the transportation from the source to the user. Of course, with this protection, your pipe service can last 50 years at least. Yeah. Here is a project list that you've seen is India. And then the next is outside India. So you can see many projects been done since 2003 until now, still using a 3LPE service for water pipes. So these water pipes with 3LPE steel pipe for water services has been in use in India since 2011. So it has been a long track record for being an application in this water. Next. This is outside India. Also, we see lots of projects until 2019, I think. Yeah. So this is a list of the project that you can take a reference and find out about this because many projects have been used to run water pipes. Okay. Yeah, so much about materials and all the other services. So we can see that PE is an innovative material for water pipe application, overcoming many issues that we highlighted: corrosion, low tolerance of ground movement, as well as weak joints that will break because of this ground movement, and then water will definitely be leaked out. And what PE also has been found more sustainable than traditional piping material, with lower environmental impact and the whole life cost. So this is a thing that we need to look at for, and especially this whole life cost, because material type PE pipe could be just cost higher in the just by itself, but the whole life cost, including the services and long-term application, is a better costing compared to other material. And this PE has been successfully been used in the gas pipe application, where pipe failure is not allowed because when gas leaks, explosion, I think the consequence is too much for anybody to accept. So in the water application, the same quality mindset and practice should be adopted to reduce this NRW loss. And one key area to rectify this is to reduce or not use salt and pepper and ensure quality joint to be the norm. And also we presented our latest PE ball safe material, which is the LSH with the high stress crack resistance performance, as well as the ELSH for large diameter to address this new demand that is arising in this region. And with water scarcity, 3LPE steel pipe also provide a superior corrosion protection of the raw water that has been treated and sent to the user. So this will save a lot of costs at the end of the day, prevent contamination from the open channel, and then from losses. So all these are precious water that has been treated and being put into good use. Thank you very much for your attention.
Thank you so much, Mr. Imesti. Is there any more from Ms. Pekting Zika?
Actually, we are launching a survey here for the audience.
Okay.
But either use your handphone to scan the QR code or just go to the link here. I have a few questions which we would like to understand more about your preference of material for water pipes and also your current pain points so that we can actually provide more information to you. So I think today is just a, probably after such a long break that we could not travel to see most of you, that we have this webinar as an interim way of contacting and keeping interaction. So we still would like to continue to provide answers to the questions and help to shape the industry for water applications. So we also have our contact here. The first one is me, that's my email. Amos just presented, that's Amos' email. I also have KH, who is probably a very well-known face in the water industry for Malaysia. So do feel free to contact us. And if you already have this QR code scan to do the survey, I also invite you for Q&A. Okay, and I have Prashant and Chanchal from India also in this webinar. So if there's any question that can touch on some area that they are experts in, they will also be helping us with the answer.
All right. So do you mind if they unmute themselves, or do you want it to be all in the chat box?
I'm fine. Yeah.
I have unmuted.
All right. Okay, there's a few questions at the chat box actually. So okay, do you want me to read it for you?
Okay.
Okay, there's one from IR Hajiwan Amil, if I'm not mistaken, he's from LAP, Lembaga Air Perak, if I'm not mistaken. Ms. Peck, can you elaborate what are the advantages of using MDPE or HDPE pipes? I noticed that in temperate countries, the use of MDPE pipes are quite extensive compared to humid countries like Malaysia. Is there any constraint in using MDPE pipes in Malaysia?
Okay. Okay, I saw my colleague KH has tried to answer. I'll just substantiate a bit more.
Yeah, that would be great.
Yeah, so in terms of material development, we have P80, then we have P100. So it might seem that P80 material seems to be something of an earlier generation. However, within MDPE itself, there are also new development from unimodal to bimodal material. So today, the bimodal material for P80 is widely used for house connection. For example, in China, they are using it for gas. So correspondingly, there is also a yellow version for gas pipe as well. So the advantage of MDPE is of course the flexibility. And with the advanced technology, we are able to also tailor-make PE80 to have very good rapid crack propagation. Definitely, it has very good stress crack resistance as well. So besides, the only thing here is it is a P80, and the other material in the market, probably PE100. It's just a matter of, different material have different strength. If you are using low pressure for household connection, then an MDPE80 will actually still do the job. So when we talk about temperate country, because temperate country, they might be more concerned about flexibility, because if it's getting colder, the flexibility of the system may be, put in more focus. Therefore, MDPE is also, a material of choice in some cases.
Okay, thank you. If anyone wants to unmute themselves for the questions and answer session, please do so, yeah? Okay, let me check if there's any more questions. Do you want to elaborate more about the one that KH Liu has answered also?
Okay, let me just have a look. Maybe KH, you want to chip in as well? KH, some of the questions.
I can little bit add to that.
Okay, Prashant, please.
This is regarding the MDP and SDP. Okay. See, the MDP being the softer material means the density is less. So you have a coiling is much more easier, that thing. So when you go, the MDP pipes are being used for the household connections where you expect the coiling of the pipe will not be say like a 20D or that kind of a thing. It may go little, the radius can be little lower. So in that case, being the softer material, there will be no stress point at that point where it has been coiled, and there will be no what you can say the failure in that point. So that is more relevant in case of a water. And you can have a color code with the MDP otherwise. So you can have a black or blue or whatever you feel. And in case of a gas, the MDP has a property which is more relevant for the critical pressure, which is not relevant to the water quality, water application. So this is the main reason why people go for MDP in case of this. But regarding the humid or this, probably SDP, rather the MDP and SDP will have the same thing. There will be no differentiation regard to humid and this kind of a thing. Absolutely no problem on that issue.
Thanks, Prashant. Thanks, Prashant. Would you like to share a bit on repairing of PE? Because there is a comment here that PE maintenance is quite difficult in terms of getting an expert contractor to repair the PE pipes. And need really dry condition. Yeah.
Sorry to cut you both for a while. Do you mind switching on your camera so everyone can see?
Yeah, maybe Prashant.
We can have a discussion.
Yeah.
Okay.
I'm just afraid the bandwidth.
All right. Thank you so much.
How do I get Prashant?
Yeah, I'm putting all of you on spotlight first.
Maybe Chancha want to also on your video?
No, yeah, I will do that thing. Okay, because I have to change my background. It's coming the reverse side. Anyway, meantime, I answer that thing. So the issue is one second. Anyway, this is not there. I will be like this only. The issue when you do the basically there are two kinds of repairing. One is when you have a problem and mostly the P pipes failure are happening because the external damages, because of the poke lane or some kind of a thing hitting, or if you're opening the trench and there is a excavation goes on and then hit the pipe. So there are two ways. First is that the easiest way is to use the electrofusion fittings at the site. You have some kind of like a clamps coming into that. You can put the clamp through the electrofusion fitting. So the particular area can be sealed if there is a damage to in that one. And second thing is that you also use the P pipe if you have like a squeezing is possible. So you can squeeze the pipe from the both ends and repair the pipe using the pipe and flange assembly. That is also there. But anyway, you have to use the welding machines to put the flanges. The easiest way is to do the particularly electrofusion fittings or use the compression fittings. And the third, another option is to use the saddles. So mechanical saddles are available where it can cover that. Probably I can share the few metallic saddles. So you can put the saddles and temporarily repair the pipes. So if you have like a a small opening happening, then you can put the saddles. But if you have a cut down of the pipe, then use the electrofusion coupler and repair that thing. So what I will suggest is that the pipe network team, they can have the different kinds of couplers available with them. Say if they are using 4 sizes of pipe, they can have at least 3-4 pieces with them and 1 electrofusion machine. So that will be very handy to repair the pipes very fast. Another way is to do the online repairing. Means without doing kind of repairing, means you want to take out the water connection. There you have a tapping saddles you can fix online. And at the last stage, there is a cutter. You can use the cutter and then keep the pipe, means they can use to allow the flow to happen. So this is more popular in the gas where they do not want to close that the operating flow. So it will continue online. They will do that thing. So these are the various technology methods. Probably I can share you the slides through our team, that how these things being taken care locally.
Thanks, Prashant. There are also quite a few questions and in the chat, and I think KH has also answered them. Maybe KH, is there anything you want to pick up and elaborate a bit more?
Can anyone hear me?
Yeah.
Yeah, sorry, I'm from a mobile because I think that the laptop for some reason has some error message, so I'm calling my mobile. Fine. But I see some questions on backfill, FWAD and all that. I think the important point to make about backfill, especially in Malaysia, is that, and not in Malaysia, for developing countries like in Asia, even India, the quality of backfill, as everybody knows, is a big question mark, because you may specify a good density or certain sieve size to use for the backfill, fine soil and all that. But when it comes to actual site conditions, these are not really done, because the workers are not always following things to exactly to the requirements. So you will realize that for certain pipes, rigid pipes, right, that comes in sections DI, even our PVC, sometimes this cause the failures, because when you got settlement or when there's water logging, then the pipe sections of the pipes fail, and sometimes even deflection as less as more than a few percent will cause this kind of rigid pipes to fail the connection. So that's where PE is beneficial, because PE is fuse jointed, it's fused together, welded. So once it is welded properly, if they do it properly in dry conditions without any contamination, the pipes are actually what we call end load resistant. That means you cannot pull the pipes apart, and it will fail in the area that is away from the well actually. That's why PE, for this reason, once welding is done or jointing is done properly, is very resistant to actually any soil settlement, any backfill quality, poor backfill quality, no proper backfill also. And you will see that once the jointing is done properly for PE, that's the most important thing, it doesn't really feel at the joints. That's why it is quite resistant in many areas like the marine areas, whereby the deflection and the wave action is very severe, but yet it is resistant. I think that's an important factor to make here. So a lot of civil engineers who are using the calculations, the civil engineering calculations for rigid pipes, when they apply the rigid pipe principle into a viscoelastic material like PE, sometimes those calculations need to be moderated or modified, I think. We have some examples of that. I mean, please email us. We can share some of those things, but you cannot use the kind of rigid material calculation when you are designing for PE pipes, for whether it's in buried or even standalone exposed pipes anyway. Just to make that point. Thanks.
Thank you. I see that Chandra is trying to also answer a question on HDD. There are actually a few questions. Chandra, would you like to support here?
Yeah, the first question was about, how is Hdpe suitable against dragging and pulling of the pipe during laying and installation work? Now, it is basically done by dragging and, pulling only, especially the pipes which are cut in 12 meters length. Maybe coils are handled a little bit more carefully. But HDP, number one, it has got excellent abrasion resistance. I mean, the abrasion tests show that it has 7 times more abrasion resistance compared to metals. And number two, especially if somebody uses high stress crack resistant material, these materials are designed to give 50 years lifetime despite notches and scratches, which can be up to say 10% of notch depth of the OD. So HDP is quite okay with dragging during the installation work. Second one is HDP pipe is not suitable for install crossing trunk main road, as the area will be subjected to aggressive and extensive traffic load. In fact, basically HDP pipe strength were being tested in the initial days by running a truck over the pipe, and nothing happens to the pipe because it's flexible. So HDP pipe basically, even if there is a huge traffic load, it will momentarily deflect itself, pass on the stress to the surrounding soil, and the moment the load is removed, it comes back to its original shape. So heavy traffic load, in fact, doesn't have any effect on HDP pipe functioning. It will never break, being flexible. Number three is irregular level and depth of laying of pipe will affect the integrity of flow of water inside the pipe, and the future repair work for the pipe installed by means of HDT is difficult and extensive. I'll address the second portion first. Future repair work installed by means of HDD. Now, once you have selected a good HSCR material and done the welding properly, since the pipe already laid underground, there is no chance of third-party damage. HDP pipe is designed for more than 50 years lifetime, and welded joints are always stronger than the pipe, which has been tested enough and more times. So repair and maintenance really is not required. They are more required probably in exposed areas where there is a possibility of third-party damage or damage by other utilities doing excavation in the same area. Irregular level and depth of the laying of pipe. Here it is specified in the system how many times of the OD should be the burial depth, and it is invariably lower than the ductile iron or similar pipes. Basically, you need to do proper, prepare a proper compacting of the soil. That makes your installation perfect. So my colleagues can add anything more if they want.
Actually, let me give you some example of the SDD, what we have done. At least in the metros now, the getting the permission is very difficult, open trench. So complete, you want to do the complete looping of the systems. Everybody is going with the SDD operations. And at least in the 3 metro cities, this has been used. So we have a specific material for that. So what people fear when they go with the SDD is that whether there will be scratches and things. So normally the high stress crack resistance material will not have any issues. At least in India, this is very, very popular SDD through the SDP. And we have a specific material with that. And regarding the dragging and everything, to best of my knowledge, if you are not scratching the pipe more than a 10% of the wall thickness, I believe there is no issue. But if you drag the pipe on the very rough edge and there is the thickness goes off more than 10%, then probably you should have a concern in that kind of a thing. But it's a regular practice to pull the pipes in the trenches or outside and then put it into the trench. So SDD, and even you do it outside. Regarding the backfill, I will add it that it is a good practice if you have a soft soil and there are no stones. So use that, the same backfill, no problem. But if you know that the trench will have a soft soil first and then the hard rock will come, try to separate out both the things. So probably the soft soil can be put it on the left side and on the other on the right side. And then when you backfill, first put the soft soil and then over and above, after say 1 feet, then you can put that kind of a thing. So this is a best practice, and the contractor can do that very easily. And if you feel there is a crossings or something, try to use the corrugated pipe, or you can use RCC pipes to cross the pipe. Otherwise, if you can get a higher rated Hdpe pipe, then probably will not have any problem. There are tables available which pipe pressure class can take the how much of the earth load. So these are quite available, and one can refer to that. Probably one presentation on the best practices on the installation. Probably Peggy, I will send to them so she can share with you, or Amos can share with you. So that will give you the idea that how we are doing that.
Thank you so much, Mr. Prashnan, for the elaborate. I see our MWA president have raised his hand. Can I pass the screen to him?
Yeah, thank you very much. So I have few questions, a few points I want to raise. Number one is pertaining to some, I think the design issues brought up by Mr. Lau, KH Lau, on the design of anchor block and also truss blocks on other design. I think this is important to get more information. If Mr. Lau is aware of the uniform technical guidelines for the water industry in Malaysia, published by SPAN, can get it from the website. There has standard design. I think if you could look at it and if it's found to be inadequate for the purpose of PE pipes, because that was actually for all type of pipes. So I think we could actually get that response and also your comment on that. And also the mention about latest specification. I wish that Malaysia should actually adopt the latest specification, and that can be actually always updated in our rules of water supply, kaedah bekal air, rules for water supply. So I think that is actually being amended from time to time. So we wish to know if there are new specification being used for the PE pipe. And then, of course, 50 years sounds long, but actually it's short. I think when I started working in 1984, people used to say that, oh, this pipe will last for 40 years. I think I've been working nearly 40 years and my pipes are all going to be gone, you see. So I think going for a longer lifespan would be something that we are looking for, because if it's going to be just 40 years, then it's not much better than what we are having now, which is actually 40 years. But then 50 years, so it's another 10 years. Maybe, I don't know, because I think it can last longer, but I don't know why sometimes manufacturers tend to put at a very, very conservative period, which I think is not going to be for us as planners. We think that, oh, that's not enough. I think we want 100 years or something like that. So I think that is actually something that we could actually explore if we could find explanation to that. And I think for the question pertaining to repair, I think there is another thing that if the supplier, I mean the Burush could actually advise us on simpler and faster. I think that was actually answered earlier by Mr. Prashan, I think. So I think, okay, probably some document, some compilation of documents should be shared with the rest of the audience so that we can actually improve our style, I mean, our way of doing things. Okay, there are a few points that I would like to raise, and I would like to have the response from the speakers. Thank you.
Thank you, Encik Muhammad Asari. Yeah, on the span guidelines, we are aware of it. Actually the MPMA working group is actually looking into it, and they actually started looking at it around 2018 and 19. But of course, it couldn't continue in 2020 because of what happened. So there was a delay. But my understanding is the working group is doing some work there, and they're getting some feedback into the ministries in span as well. So I think this is just a delayed action. But you raise a very good important point. I think we will together with Pixel and Amos, we will strengthen our push to support the working group, and then see if they can add any new recommendations to this span technical guide, because it could be updated like what you said, and it should be added with more updated information as we have now. So you're right about that part. And I think it's an action, Pixel. I think let's discuss this when we with the MPMA team, how they can do this, because this is a pending action actually from 2019 already. So it's not new. It's a good reminder. On the standards review, Pixel and Amos are very actively involved in with giving comments to the different MPMA members who are asking for comments, as well as MPMA when it comes to the MS 1058 and related standards. That one I'll let Pixel comment on it later as well, Amos as well, to comment on this thing, because ongoing action. And I think on the last thing I remembered about your part was the lifetime. Actually, the TEPFA has already stated that a lot of residual pipes, PE pipes that are 30 years old, 20 years old, dug out from Germany, UK, that they've done research on, they've seen that the lifetime is actually predicted to be even beyond almost 100 years already. So it is there's a lot of data for these kind of things, and there's a lot of confidence that the data is showing that it's even more than 50 years. But probably for conservative reasons, people are still using 50, because it's always hard to wrap your head around something more than 50 years, because that's just it's even longer than a typical career. So maybe people just stick to 50 years because for conservative reasons. But the pipes in Germany, in UK, even in Denmark today, TEPFA have published results in their website that pipes that are dug out from the ground of Germany, 20 years old pipe, they dig it out, they do tests on it, they see that the remaining life of the pipes that is already 20 years old can go more than 50 years. So if you add up in total, it could go almost 100 years already. So there's a lot of data available in TEPFA now, the European Plastic Pipes and Fittings Association. So feel free, we can connect you to these resources, or you can go to the website and search this for yourself. But I'll let my comments, my colleagues comment on this.
This question of how long will it last is a very, very favorite question. That's the problem.
Of course.
If you want to suggest this one, how long will it last? 40 years, 50 years, don't. So
correct.
That's why I think
just a comment anyway.
It's good to be conservative, but sometimes it doesn't help.
Correct. Fair enough. Good point. Thanks.
Okay, if I can just add a few lines. Basically, it's a very simple calculation. Plastic pipes are tested for accelerated test at 80 degrees centigrade for 10,000 hours. Now it is said that if you reduce the severity of testing by 10 degrees, your lifetime becomes double. So 10,000 hours is about 1.5 years. So 1.5 years at 80 degree means 3 years at 70 degree. Like that, if you calculate at 23 degrees centigrade, you will reach more than 50 years. Now what Boruj has done is, we have tested our material as pipes, not for 10,000 hours at 80 degree, but for 19,000 hours. That's why we have the tested data to say that our material will last for more than 100 years.
Actually, I can share that there are 2 phosphoric acid pipelines being put up on the rack when the ship comes, you get the sulfuric acid pumped through the pipeline. And that experience, at least 32 years, I am seeing that pipeline working fantastically. It is exposed condition and being used for the sulfuric acid pipeline at the Sikka terminal in Jamnagar. So there are many cases, I work almost like 32 years. So I am seeing a pipeline which were put up before me, and they are working very nicely, not only for the water, but for the, the chemicals, where the corrosiveness or kind of migration and everything take place. So it's very, very, very confident on that it will go beyond that.
Okay, I think maybe a word on on Malaysia standard. Maybe Amos, you are also giving some input to Malaysia standard, so you may want to elaborate a bit.
Okay. I have received a request or invitation from CRIM on the feedback or input for their revision of MS 1058 because they were checking and there was no resin manufacturer providing input. So they invite. So I pull out the latest ISO 4427 and EN 12201, and I run through the latest standard against the current MS 1058, and I provide them the input and what has changed and what need to be addressed to upgrade the current MS 1058, which is a 2005 version. So they have received the information and they are looking at the information to review, and they will be working on it before the revision comes out. Yeah.
Thanks, Amos. I think we also hear about repair procedures and also how we go around giving some recommendation to span design. So these will be some action we'll take away from here and come back on that. Do we still want to take some question? Actually, we still have some question on the chat box.
For the chat box, I think better go for the chat box questions.
Okay. I think there was a question on fingerprinting. Maybe Amos want to talk about fingerprinting. Is it still possible after 10 years?
Yes, there is a possibility, but the thing is, why wait 10 years? You should, before installation, I think it's the better opportunity to collect the pipe to check rather than you install and then you wait for things to happen and then I want to know whether this pipe is made of a virgin material, whether it will last how many years. So it's best to check before installation. Then you have a more confidence that once you properly fuse the pipe, lay the pipe, and you are peace of mind, you say, okay, I don't need to do any maintenance to this pipeline and it will run for at least 50 years. That is the intent of this fingerprinting, to check prior installation. Of course, after 10 years, you still can check it, but there is some factor that you need to address. Is there's some degradation could have already happened that could have changed some of these properties that is in the pipe itself. So there may not be a 100% checking, but could be an indicative that this material, this pipe is made of material that's of virgin, because some losses during the services and some loss in the maybe additive or some changes already happened during the service. Anything to add?
No, I think that's a good answer. So there's a question about jointing P80 to P100 pipes. So do we agree that PE pipes produced from P80 can only be welded by electrofusion coupler to P100 pipes of the same OD but a different SDR?
Otherwise, you can use a flange joint or any mechanical joint.
Essentially, different SDR should not be joined together. But because P80 and P100, they have different strengths, so to carry the same PN, pressure rating, they will be coming out with different SDR. So yes, yeah, like Prashant say, you can either use electrofusion or mechanical fittings. There's a question here about submarine pipe, actual length of submarine pipe across a river. So how do we determine the length? Because different consultants come up with different extra allowable length. Any answer offhand?
Okay, when you do the submarine pipeline, you need to know some basic details of the bed, how much depth of the bed is going to be that. So that much of extra length you need to have on the shore, offshore and onshore combination. So if the total length you expect to be say X, then you need to have at least 10% higher, so that when the pipeline sink at the bottom with the concrete blocks, so you don't get the pipeline hang from the both the ends, so it is loose. So that is only the combination, and these data are available reverse also. So but it is better to have some extra 10% more length than expected, so that you have no issue of stretching of the pipeline or hanging of the pipeline from the both the ends.
Thank you. I think I exhausted the question on the chat.
I think there is a one question that
Okay.
PE pipe requires an expansion joint for a long exposed pipe installation. This is really a very nice question. Expansion joints are required Hdpe because the pipe keeps on little bit of changing the length. What you can say, at the cold time probably pipe will shrink little bit, and hot time it will a little bit expand. So probably feels is a better way to handle this is to keep when you do the pipeline installation, lay the pipe little bit in a snaky way, so that if you are doing the installation in the morning, will not have any problem. But if it is in the sunny condition and then you hold the pipe tight, then probably it will try to pull from where it has been held. So just put the pipeline in a loose way, little bit snaky, so that whenever there is a shrinkage or kind of a thing, the pipeline will pull straight, but it will not put the pressure at the both ends. So that is the way the people handle it. Now the expansion joints are also available. If you want that kind of a thing, it is there. Or you can have a small loop in the pipeline if it is a long pipeline, so that whenever there is an expansion contraction taking place, the loop takes care of that. So that is the way the pipelines are being laid in the water supply. Even you want, you can have there is no question on the exposed. If it is exposed, it will take place only. You don't have to worry. The problem happens that when you are holding it inside, and at the inside the ground, the changes in the temperature will not be as much what you expect. Below pipelines, the temperatures will not change. Above ground, it will change, but if it is free, no problem. Just keep some cushion, snaky way. You will not have never had a problem.
Thanks, Prashant. So how are we doing with time?
We have another around 5 minutes, if that's okay.
So any question? Anybody want to just raise the question?
You can unmute yourself if you have any more questions, yeah? Right, I guess it's a silence from all of us right now.
Okay, I think I would like to break the silence a little bit.
It's a good situation that all the queries have been answered.
Yeah.
All the questions. My question is going to be a hard one, a difficult one. You know, I think looking back, I have been using Hdpe since 1988, I think, 1988. At that time it was PE 63, I believe. So I knew some of the failures of Hdpe. Then later of late, I have been involved in a lot of auditing and whatnot. There seems to be some issues pertaining to poly pipe. So I think those are things that need to be also addressed and always brought. I think the one mentioned by Amos about the fake pipe, I think that is very important. I just knew about about it today. So I think probably that's why we need this sort of webinar, so that we are aware of what are the problems that may cause what we say in the past as some problems pertaining to P pipe. Maybe I must have a lot of more experience than I do. So probably can we share a little bit on how things are what happening and how do you actually overcome this?
I guess the experience is collective from all regions, from Borouge, other officers as well, operating in China as well as Middle East and India, because this is just not an experience in one region, because these fake pipes are generally in many places because of they know it's a very good money to make. So they come up with a fake pipe to copy the authentic pipes, try to get more revenue out of their these fake pipes, and not thinking ahead how they this pipe perform. I guess a lot of things is to do with getting, as highlighted, first thing, the material itself has to be of good quality. Once you have a good quality raw material, then you can go up to have a good processing, and then with the good quality check, and you have an installation that people are certified and use the correct tooling and operate at the required window, and this will give you a pipe system that will run as long as you want, as long as you you can operate, because the foundation is correct. You have the right material. If you have the material that's wrong, then whatever after good pipe, good installation, run in the right window, the foundation is wrong, whatever good, it will be already destroyed. Yeah. So first thing is to have the right raw material. As we follow the standard, if you go by the standard, you need to have a good compound material, like what Pixel has shared in the slides. If you have pipes that are even P100 natural plus carbon black, there is this window that gives you a lot of stress. Once you have stress, you cannot ensure the pipe integrity during the service. So important to have is to specify the right material and of a good quality to make pipes. Yeah, that's the basis to start with.
In India, what we do is that like a gas, it is 24/7 inspection. So somebody is from the gas industry do not want to take any chance. So they will have a full inspection during their production. Whereas in water, depends on the customers. If it is like a private customers, they monitor, they go physically, they ask or they put someone from the industry to take care, to look into the production and everything. And people are not using the other than the recommended material. But frankly, I always believe the specification should always have that you will carry out the 24/7 inspection. You have a right to, to look into the prior production, to check the quality of the raw material during the production and after the site. It's your right, you exercise it or not, but in the tender, it should be there. So at any moment of time, legally also, the owner, the pipe, you can always audit that and produce the result. But if you don't have in the tender, probably there are always dispute that we had given the good pipe, you accepted it, now you are saying like this. So there are issues. But put it into tender specification, the best way. You do it or not do it, that's a different issue. But I suggest always put into the tender.
Yeah,
Okay,
I will just add one more
allowed to
line
ask?
if you allow me. See, British Gas started using plastic pipes for gas in 1963. And today, almost 100% of underground gas distribution network is only polyethylene, MDP and Hdpe. So in gas, Hdpe has passed acid test, but in water still you see failure. Why? Because if there is a gas leakage, fire, people lose their life. So people take care. People even today feels water loss is of no consequence because nobody dies if there is a water loss. Therefore, we can take all liberties and use variety of qualities of material. So when it will prevail upon them that water will actually become a more scarce resource than hydrocarbon, then probably things will change. Earlier, people were not bothering about water loss, but today I see in every project, they say that our first objective is to bring down unaccounted for water from more than 35% to less than 5%. And this is only possible by using a fully welded system. So if we look at best practices of oil and gas and try to implement them in water, it will do a lot of good for our industry.
No, I'm raising this point. Just now, Mr. Prashan mentioned about 24/7 supervision on production. I think maybe Borush could actually come up with something in between. I mean, of course, we can put that in the contract, but is that going to be practical? So I think that's one thing. I'm raising this thing because, you know, the market talk about HDP can be damaging if you didn't have proper explanation on product. As mentioned by all the speakers, that this is good, has been good for the oil and gas, but what's the problem with water? So I think that has to be addressed, and that part has to be, that gap has to be closed. That is my last comment before I think we are going for the closure. I mean, maybe you can respond, Mr. Amos. Amos, please.
Yes, I think this is not only, I agree with Prashant and Chancha's comment, because at the end of the day, this is not just one party's commitment, because water scarcity is a global issue. I think we need to be understand that this is something that we need to take care. Yes, nobody die, but you're running out of water, you waste the resource to treatment the water, and then you waste it. That's not necessary to do this thing. And Prashant's case, because even in Indonesia, the same thing happened. The company that make gas pipe, they have the end user really stand by just to make sure the quality is there, because they know that its consequence is too big to have a non-pipe that are non-compliant to the requirement. So I guess the whole value chain need to be taken care of. From the resin producer, you need to produce the quality that is suited for this application. Pipe maker should make the pipe according to the standard as well. And then the end user should instill, maybe with the tender, the requirement that they will do audit to make sure that people are on their toes, to make sure they use the right material, make the right pipe. And of course, at the end of the day, all the people need to be conducted training to do the proper installation. They can do a proper job, and then this whole thing will put in the good system to run. So not individual party, it's the whole from the first resin producer until the end user. They need to be committed to ensure the pipeline is of good integrity for run for more than 50 years.
If I may add, so I think right now, anyway, Serum is doing audit for resin suppliers to make sure that our material are complying to Malaysia standards. Of course, Malaysia standards needs to be updated. That's a different story. What we are trying to offer the fingerprinting as a service to the industry, to the water utilities company or gas companies, is to exactly plug the gap. Here that we know there is a standards, there are some audit being done, but there along the value chain, we really can't really secure every single value chain. So, you know, a check that we are offering here for the China context, every year we are analyzing more than 400 pipes. So that is the scale of capability we can do for analysis. And we're actually offering it to Southeast Asia as well. So in any case, the water companies feel that they need this service, feel free to approach us.
I believe PEGSE is better to have. Now you have regarding the resins and pipe. I think something on the installation and the best practices for the welding and everything, probably that will be the complete loop we will be completing, so that they know from the resin to the up to the installation good practices. So that will help them to, to check.
Yeah.
Thank you so
Agree.
much. I think it's time for us. It coming to the end already. Is that okay? Yeah. All right. Can we have everyone? Your mic is on mute.
Maybe Chanchai want to close up something, because everybody has talked. Maybe final word.
Yeah,
Oh,
it
okay,
was
from
a
India. Yeah.
it was a wonderful gathering, and I really enjoyed being in company with all of you under the able leadership of Muhammad Asari Daud. Thank you very much, and I wish there can be more interactions in future, which helps all of us. We come to know, what are the problems in the industry, what are the things happening, and you also come to know what are the developments in raw material and things like that. So if we go together, definitely both of us will benefit. Thank you all very much, and it has been a
Thank you so
pleasure
much.
with you.
Thank you.
Thank you. Before we end, Raja, sorry, do you have any closing before we end?
Yeah. Why not? Little point that I want to just share again. So I think this has been a very interesting and fruitful webinar. I think a lot of new things that I learned today. I think probably we have not listened from PE pipe supplies for quite some time. So today I think is a very good revision that we are getting from this team. I would like to, on behalf of the Malaysian Water Association, I would like to thank everyone. Ms. Peck Zikang, Mr. Chanchai from all the way from India, okay, Mr. Amos, and also Prashan, also not forgetting Mr. Lau, okay, Lau, for I think being very informative to us. And I think also I would like to express my thanks to our fellow colleagues, the participants, the viewers, and last but not least, our secretariat for organizing this event. I think it's very important that PE pipe will be looked into as one of the what we call that substitute for the so-called asbestos pipe that we are actually going to actually get it out from the system. I think there are a lot. I think not too far from 50% of the pipe need to be changed. So I think if you want to know more information, probably we have all those information in our Malaysian water industry guidelines, which you can get it from our secretariat. Sometimes you have to pay. I don't know. This time maybe they can give it free. Maybe the past one. You can see from there how much pipes need to be changed, and I think that's important for the future of our water industry. I think NRW is not a compromise at all. We need to get ourselves back up with all new technology so that our NRW can be improved from what we are now 35% to probably something like 25% in the future. So I think with that, I would like to thank everyone for this opportunity to be together. And I hope we will see face-to-face not too long from now. And of course, if we have webinar, please do join us again. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Before we end, can we have everyone to on
yeah,
their camera for a photo session?
Okay, come, let's take pictures.
All the participants, please, on your camera so we can see your handsome and beautiful faces.
Our counselor is there, Mr. Tam.
Mr. Tam is there.
Who are the counselor? Amel, apa khabar, Amel? Perak, okay. You can dine, Perak boleh dine,
Okay, 1, 2, 3. Okay, there's 3 pages here. Okay, wait, yeah. 1, 2, 3. Another one. 1, 2, 3. All right. Okay, thank you so much,
Terima
everyone.
kasih semua. Thank you very much.
Thank you very much.
Thank you so much.
Hope to see you guys on our
Take
next
care.
webinar.
Okay, take
Bye.
care,
Thank you.
everyone.
Okay, thank you, Ms. Peck.
Thank you so much.
Bye. Thank you, everyone. Thank you, Khairul. Thank you, Rada. Thank you, Rada. Backup.
Ramai lagi ni.
Kita kena bagi tahu Dr. Khairul di dalam ikut doktor.
Thank you. Bye.
Andy Jo. Okay, Khairul, thank you.
And meeting terus saja.
Okay.